Imagine learning a skill, then being sliced in two, and still remembering it when you're whole again. Sounds like science fiction. It's real. In the slim, translucent world of planarian flatworms, memory survives being rebuilt. These tiny worms can do something almost supernatural. Cut a planarian in half and each piece regrows the missing parts. Heads regrow tails, tails regrow heads, but scientists didn't stop at anatomy. They asked a stranger question: what about memory? Researchers trained planaria to avoid a light or to twist away from a shock. They taught them tricks, simple, repeatable associations. Then they performed what would terrify any animal. They decapitated them. The worms regrew new heads, and the astonishing part, many of them still avoided the light. The learned behavior came back as if nothing catastrophic had happened. That tiny result flips a giant assumption. We think memory is a fragile web of synapses, a map held inside a specific brain. But here, the map seems to survive demolition and reconstruction. How could that be? New science points to clues hidden in the worm's builders, pluripotent stem cells called neoblasts. These cells are the raw material for every new tissue. They carry molecular instructions, epigenetic marks, RNA signals, protein patterns, that guide how a brain is reassembled. In other words, when a planarian rebuilds a head, it doesn't start blind. It carries a set of biological blueprints that already encode information about past experiences. For decades, there were even bolder claims. Researchers who fed shredded trained worms to untrained ones reported partial transfer of learned behavior. That idea of memory as transferable biochemistry sparked fierce debate. Modern techniques don't accept wild claims without evidence, but they do reveal a deeper truth. Memory may not live only in connections, but also in the molecules that shape those connections as they form. Think about what this rewrites. Memory isn't just a fragile file stored on fragile hardware. It can be an emergent property of how living tissue organizes itself, resilient, distributed, and written in chemistry as well as wiring. If a creature can lose its head and keep its past, what does that mean for our own ideas of identity and continuity? This tiny worm forces a huge question. What really makes you, you? If this blew your mind, hit subscribe and tell us in the comments. Would you trade your memory for immortality?